and I'll send you this file, but essentially we have our circle. In order to make the UVs work, it was as simple as changing this archetype from closed to open arc. And then it fixed the UV issue without having to do anything fancy. So it was all still the same bit, right? So I was creating, my U value on my circle, and I was creating my V value on my line. And then the only other thing I added was this section here where I adjusted the P scale, which is how thick these are, right? And I used a ramp. So the CH ramp, P scale. And then I used this curve view, which this is actually, you can use this, and we could have used this attribute instead of this. Like we could have done something else, which is if you just check this on when you resample, it gives you a value between 0 and 1 along the length of your curve, which is what this was doing also. So
okay,
it makes it a little redundant, but that's fine. And so when we come through here now, it gives us these circles that are copied, and then we polyloft between those circles, right? And then this is, I was playing with some adjustments to the UVs, like so that way I could make sure that they were truly square. And then we look at the quick shade here. And so what this does is it gives me an attribute that I can make some adjustments to my UVs to ensure that I'm getting square UVs. All right, so I can come through here and, like maybe down here, it would be, right? You can just see how I'm, like how that's like this giant non-square UV. None of these are perfectly square. So it becomes about finding a way to make those as square as possible. So now we're starting to get better square, but see up here, we're still not. And so now I have the ability, I could maybe select this and make this a Bezier on all of these. And so you'll get a better fall off between them, so you don't get that hard line. It gives you the ability to make some adjustments, find something that gives you something that works.
So without the attribute wrangle that you have, it doesn't have any UVs on it?
No, because you have to create that, right? So using the polyloft, it does not generate UVs. You have to create those on your own. You have to manually create UVs.
And then you create it using the attribute wrangle.
Right, because here's another way that we could do it. We could have done it like this, UV texture, right? And so we can come here and, let's take it off of the polyloft. Let's just copy and paste this so we can see all of them. And so with this, I can say orthographic y-axis. And so you see here, that's not very good. So I can do, instead of orthographic, I can do cylindrical along the y-axis. And you see there's our cylindrical, and we could fix that boundary seam. And so you see now we have UVs, and it's basically from here to here. We could play with some of this stuff like 0.5, right? No, that's 1.5 to get something that feels more square, right? So this is a basic UV kind of thing. It's a default that works. Now, one of the things about it is if you look at all of our UVs are backwards, right? Whereas if we look here, our UVs are correct. Now to fix this, we would have to do something like this, like -1. And that gives you a proper UV. All these solutions work, and all these solutions are right. They're just different, right? So like what I did with this in trying to give myself something that allowed me, so if I had my P scale changing, so that I wanted big features down here, but then finer features up here, it gives me the ability to do so. right? That essentially you could, if we're looking at this one, let's do this. Let's take these guys and get rid of them. Let's take this and make its value greater than, let's go 3. Right, just so you see like how I have this control now over the density of my UVs.
Uh-huh.
So this way down here, it'll feel like, let's do an actual texture. Let's do the shake, copy and paste. And I'm going to go ahead and instead of using the UV, I'm going to use the mandrel. So let's come into here. And I think it's, no, sorry. Mandrel. So it's this picture of this monkey, right? So you can see that here it's taking that much distance. But then as we go up, we start to see that, we're repeating the same pattern, but they're in Megascan, they're supposed to be tileable textures anyway. So it gives us, you'll be able to see how much repetition you have and how much map will cover this big section versus this little section. And so now you can start controlling how that's working by adjusting these UV maps, right? So these UVs. And so, here we got a good variation. It's pretty even along the entire thing, but maybe not quite as much up here where we need to, bring that area down just a little bit in there. So now, again, it's about giving myself control over this, where a linear calculation wasn't enough. I needed to break this up a little bit more. Or maybe based on what you need, you actually want it to be something like, let's see, something more like this, right? Where in the older section of the tree, the bark looks really big, but then as it goes this way, it's going to start feeling smaller and smaller as it goes, right? Does that make sense?
Yeah.
So
Are you stretching that just on the y-axis, or is it stretching?
yes. So
Okay.
because what happens here is this is the way we set up the UVs. Go to UV viewport. The UV goes all the way across, right? Because those tileable textures are designed to be tileable in both directions, right? So it tiles this way
Uh-huh.
and it tiles this way. So what'll happen is if you don't have your UVs going all the way across, right? If your UV stopped here, you're going to have a seam because the texture tile isn't going to line up from here to here.
Okay.
You
That makes
won't
sense.
you won't be that portion. And so you want to make sure that it's going all the way across. Now, because our branch up to down, it doesn't matter. And so if we actually zoom out of this, we'll see that we're actually using 4 UDIMs here. But because we're not using UDIM textures, it'll just repeat that texture in all of these other UV tiles. So it's just a way. And since this tile's from here to here, it's no matter what, we know we won't have a seam. Right? So let's use a different texture to help with that. Let's go back out here. I'm going to use, I think these bricks are a tileable texture. There we go. To give you a better idea, right? So if we did this in a way, we came here and let's say, let's generate that. So we're going to look at our geometry spreadsheet, and this is what we want from 0 to 1. But what happens if we do this and we divide this by 2? Oh, no, we want to times it by 2. All right, so if we times it by 2, you'll see that we now get half, right? So if we come back to our scene view and we look at our bricks, you see it right there. That's where the seam is, where it doesn't line up because we've only gone, halfway around. But if we remove that, we can now go all the way around this and it tiles, right? Because it's been designed to be a tileable texture. Now, one of the things we stumbled on there, if we divide it by 2, oops, it'll now tile twice, right? Because if we go to our UV viewport, we are now spanning all the way across. And so we can go to back to our mandrel. Oh, that's not our mandrel. And now we see that the mandrel is actually on there twice, right? Which again, like the UVs will only be correct when you put it in context with a texture, right? That's how you're going to determine whether or not these UVs are right. You're going to find the texture of the bark that you want to use off of Megascan, and you're going to apply that. So let's try that. Let's go. Do I have the bridge on here? Oh, you know what? I don't have the plugin installed, so it won't work. But
you're good. I can't even get it downloaded. My internet's so bad.
Oh, yeah. Well, then, so you're kind of out of luck with that. You'll have to kind of throw that at somebody else for the time being. Again, I've had to stay away from the MPS because the meds I'm on have like destroyed my immune system. But I'm off of that med now. So in the next couple of days, if you still want, I can take my machine up to the MPS and you can use this second machine if that's something you want.
Yeah, I mean that'll be honestly good because my internet's really bad. If that's not too inconvenient. If it is, I'm fine working at home.
Sorry, hold on one second. Yeah, we'll get that sorted out. We'll get you machine that way, because if that's stopping you and we want to be using that, then we'll get you set up. So, but does this make sense? Like, if we look at any of these, like we go to UV quick shade, you can see how that's repeating, right?
Mm-hmm.
So it's doing the same thing that we are. It's doing a singular wrap around, which is fine. Like this could work. It just depends. Like you may find that you want like more repetitions around, that you don't necessarily want it to be just once around, that you want it to be twice around, like this. Or as we saw here, we can actually make it even more than that, right, by dividing it by 4. And now we have 4 times around. And what that gives us the ability to do, right? So let's watch this. If we then take our U scale and our V, let's see, that's what this one is. No, that's what this one is. Yeah, this one I'm modifying that value, but we could also so now, like, obviously, I think this isn't what we want, but if you were up close to a tree like this, right, and we wanted something that was hero enough, you might want this, right, where the bark is repeating like this. Does that make sense?
Yeah.
Like,
what you just said didn't, because I couldn't. It just cut out. Yeah.
But right. So it's about adding controls here. Like when we've rolled our own system, it gives us the ability to have a lot of controls, and we could go in and add a lot of the stuff that this is doing, right? Like if you came in here, you could go find the sections of this that was adding mesh noise, right? So that's what this is here. I think if we let's unlock this. So if we come in here and we look here, here's that our mesh, and then this is adding that noise that Mike is liking, right? So mesh noise is right here, which is taking It's creating some attributes here based on its radius.
Okay. Because wouldn't that just come in the displacement though of the atlas texture?
Yes, it will, but this allows us to add some additional geometrical breakup
Okay.
on top of that. So, it again, it boils down to, like what is it that we're trying to achieve? And so if we look at this, let's see, at mesh noise. Yes. Right. So you could come in here and you can see that this is, what does it bring me in? Radius and gradient. So, I mean, we could rebuild this to make this attribute, right, to pass this information out. And you see that it's doing this turbulent noise, and then it's just displacing it by that amount. So you could either do a complicated system like they have there, or on ours, we could do the same thing just by doing this attribute VOP. And right now, this is going to be a lot more simplistic. And then we come in here, and I'm just going to put down turbulent noise. And put down a displacement. And what we do is we take our position. Oops. We're going to pass it through. And then what we want is we want to plug this into our scale. And then we're going to promote our amount. That way we don't have to keep coming in here. But now we have this amount that we can add displacement, right, to our tree just the same. And you can see that, there's some things here that we'd want to fix, right? So firstly, we want to add normals. So that way our normals get fixed as they go, right? So it corrects those normals. And then we want to correct that, which would be just as simple as fusing our points, because remember we made it an open arc, and so that they weren't actually stitched together. And the reason we did that was so our UVs would be proper. And now that we've finished UVing, we're just going to fuse those together. And so when we look at this, you see that it's all nice and closed. And then this becomes an attribute of our turbulent noise, which we can also, we can go ahead and say, create input parameters. And now you see all those get connected. And so you come up here and now we have controls of all this where we can change what that is. And, we could do something like we wanted more detail because this is based on the number of points. We could subdivide our mesh. We could also do that in the poly loft beforehand. Is we could, well, actually you can't. This is based on these. The way you would increase our, let's take this off, this subdivide. The way we would increase this is by increasing the number of points that we have, divisions that we have, right? So if we do 20, we see that we're starting to get more, right? We're getting more geometry in there that we can play with. And then if we want more segments this way, we want to change our resample, like this 100, right? Or 200. And you can see we start getting more and more detail in that mesh that we can then play with, right? So if we change our lighting scheme to something a little bit better. And that helps us to define what that shape is, right? And that turbulent noise. And then the cool thing about that is, we have total control over what this is. We could say 0.5 if we want to stretch it out and make it look a little taller, right? And we can do cool things by doing stuff like this. Let's do a twist. And then we're going to generate, do like this, we'll do a rest pose. And then we're going to twist it. And we're going to do an attribute wrangle. And we're going to say at P equals at rest pause. Okay, so you're going to see what happens here. We're going to take this twist And we capture direction should be in the vertical, and we want this distance to match whatever our line distance is. This is why like connecting attributes is always really important, that you think about things, right? So like I'm going to copy that parameter. That way I have a couple of places where I change things and the system then works everywhere. I don't have to go back and like, oh, I got to fix this thing and I got to fix that thing. Because like now that these are connected, it doesn't matter what I make this, it'll always capture the length properly. All right, so now we come in here and like we're going to twist this, and let's twist it. Let's twist it a full 360. You can see the underlying twist structure is happening, which actually, right? And so we see that this didn't change, right? But we see how it's twisting now.
Uh-huh.
And now, oh, where'd you go? Oh, it's called rest, that's why. Oh no, how do I do this? I want to.
Why does it have so much geo? Did you add more geo to it?
Yes, I did. I added
Okay, you did.
I added a ton of geo. That's not what I want. I want to. I used to do this trick all the time. Now I'm forgetting that there's a step in the middle here. But essentially what we do is we would there's a way to do this where like we take essentially a rest position. Oh, is that how we do it? Oh yeah, this is what. So you go like this. We're going to create a rest position out of that. We'll come into here, right? So that way, instead of using our position now, we're going to use dual rest. We're going to do a bind, and we're going to bring in our, it's a vector, our rest attribute. We're going to plug that into here. And we're going to do this from the attribute copy. And copy the rest. So there we have our rest position. And so now you can see that our twist, we can control the orientation of that noise as well. We can twist it around the shape of the tree. Right? This is where understanding like the proceduralism of what you're trying to generate, they're trying to give you something that does a lot of this stuff, but it's always limited because they're trying to cover a whole bunch of use case scenarios. But when I know what I'm building for, like I build the system for the exact type of tree that I'm trying to make, right? Where this is trying to say, you can make any tree with this system. It's like, cool, great. There's going to be a bunch of features that leaves out. But with this, I know that I can build exactly the tree that I want, right? Like come in here and all of a sudden you have this cool twisty tree, you know, that has a bunch of gnarled stuff on it.
That's cool.
And then,
and that's basically what Mike was wanting, yeah, just more displacement on the trunk.
right. And so
okay.
being able to understand how to create that requires geometry to be able to generate that, right? Like our lower res tree. So again, we'll come back here, and the way we created geometry was from our divisions in our circle and also from the number of resamples on our thing. So if we reduce this and go back to what we had, so 50 and this was 10, you can see that we get a lot less interesting stuff, right? Still there, but because we don't have geometry to represent it, this is all geometry operations. So it's not a texture that we can then drive from. We can do things like generate maps based on differences between two things, but that's getting much more complicated. And we can talk about some of that stuff, like how would we go about, because using like cops, we actually can take the normals, like we could, let's undo those, right? So let's see, let's go here, where we have this like really high res, we can essentially take that normal information off of this in cops, right? And again, this is, I'm only doing this to kind of get your ideas working. You come into cops and we can say SOP import, and let's do a null out here. That way it's easy to find. And we'll say out, or we'll call it high res. So we're going to go ahead and import this high res, and we're importing everything from that. So if we go to our composite view now, and we look at what this does, it's going to take a second. Set points from SOP. Image planes, we want, yeah, it's fine, custom planes. Oh, that's volumes. Let's see. No. I'll have to look this up. There's managers importing DSM flatten fetch cloud. Oh, geometry. This is what we want. And so this SOP is going to be high res, and that's not what we want. We want the geometry. I'm gonna have to look this up. I'll do a thing and post it, but essentially what we can do is we can take this and unwrap it into UV space. Mm-hmm. And oh, that's how we do it. We do it like this before we fuse this. We would then, even with that, we can take these and move it into UV space, right? So we do an attribute wrangle. So let's come back out to our scene view. Again, this is why Houdini is such an interesting tool, because you can do anything. It's a science project. So we're going to say at position equals at UV. And that didn't work. Oh, because we need to promote some vertices. There we go. That doesn't work either. We're going to take those UVs. So we're going to go from vertex to point. There we go. So now you see what we did was we essentially unwrapped. Now, when we look at this, we have repeating UVs. So it's going to put those over that. And so we don't want that in this scenario. We would want this to be like a 0 to 1 scenario. So with this, where's our UV thing that I was messing with? That's good. That's what we want. And then this one here, we want to so there, now we have that all in one UV space, right? This is kind of critical in if you're doing what we're about to do, is you have to have it from 0 to 1. So now when we remap our texture, right, we've moved this into now a texture space. So when we come into cops and we look at this composite view of our high res geometry, you see that it maps out, right? And then what we want to do is we want to be able to take its normal information, which, sorry, we're going to take this and we're going to say at CD equals at N. So there's our normals. Go back in the composite view. Oh, it's taking that. That's weird. All right, I'm gonna have to look this up, but there's you essentially can create a texture out of those high res normals that we just, remapped out into texture space here, right? So like that's all the normal detail. And then the greater the resolution that we make this, right? So we come in here and we change this to 100 and we change this to 500, right? It gets really heavy, but that's okay because we're just trying to get that texture detail, right? So we're gonna have this really high res piece of geo. We're gonna capture its normals, right? And then we can have the same thing, lower resolution, and then we'll use that as a normal map on that object. Does that make sense?
Yeah, that's cool.
Yeah, cool.
And then if it's a high geo, do you just like poly reduce it?
Well, so that's the thing
Or
is
do you keep that?
that's messy. I prefer, since you have total control here, to essentially make a duplicate of this process, right? Where we could essentially do this, where we take this and we're gonna right click on this and we're gonna go to actions and we're gonna say create reference copy. And now we have a linked version of this, right? So like all of the parameters here will be obeyed. Now, what I'm gonna do is I'm just gonna do this and I'm going to right click and I'm going to delete channels, right? And I'm gonna make this 10. And I'm gonna come here and I'm going to right click and I'm going to delete channels and I'm going to make this 50. Okay, so now if we come down here and we're going to ignore this, we don't need the flattening part of this, right? We only care about this, which is our geo. So here's now our lower res geo that's nice and clean, right? And it's got proper UVs and the UVs match, right? So if we looked at this UV quick shade, see the UVs are still matching what's going on over there. I think. No, they're not, because I need to break one more connection, which was number of points here. This is still looking at the other one. And so what we want to do is we want to break this connection here. So delete, delete channels. And now we're going to take this and we're going to copy this parameter, paste relative reference. So there, now it's connected to the right reference number. So this should give us 10. And we should right click in. So there's a few things we've got to go through and break. That way we get proper proper values. That's going to come off of there. I think this we would probably have to fix a few things in here where this is all going to be pointed to what that other one is doing. So long as we come out of this with a value that's correct. So it would take a little cleanup, but I would basically come through here until I had this UV wise is matching, because that's what's breaking here, some of our UV stuff, right? So I think this is probably breaking. It's taking values from that other one. And so it's giving us a different result. And we just make sure that our UVs line up. And now I've got a low res version and I've got a high res version. And that's what I'd go from. Does that make sense?
Yeah, that's awesome.
Yeah. So that way, instead of trying to build, like, because you could do this and then you could do a poly reduce here, right? And say that that's your high res, and then you have a reduced version, keep 5%, right? And that this is our low, but you look at that and that's like, it's kind of yucky geo, right? Like sometimes it'll make tears and there'll be some bad things in it that'll happen. Like you can see there's a bad point right there. There's a bad point right there where it didn't solve very well. So this is possible, right? You can come through here and get something in here and say, yeah, that's what I want. We could also do a remesh, right? So tab remesh. And so there, that's using the remesh tool. But if we look at any of these, right? So that one held the poly reduce held the UVs pretty good. And the I guess that's all fine. Now here's where it breaks on the remesh, right? Is you get this bad seam that happens. And we might have had that even. Poly reduce looks like it's better. But so you could do this way. I think I prefer to go this route because then I know my mesh is clean, right? Like the only problem with this is my UVs are getting messed up because of the way we've structured this. And I'm sure I can already almost guarantee it that it's happening right here because I'm doing an addition on something that then doesn't give me a good output. So that's really what's most likely what's happening here. So if we took this and come over here on this one. Let me say float float v equals at my v, and just leave it at that. The default that should. I wonder where that's breaking. So viewport.
I just left and then I came back.
Oh, welcome
It
back.
kicked me out. Thanks.
Nice. Thanks. Let's see, that's that. It's definitely happening in here. Oh no, it's happening there in Polyloft. That's strange because that gives me a full. Well, the thing I love is that you have the ability to copy. Let's see, this is of going through and seeing everything individually. I would guess that something in here is breaking. So I can continue to come through here and just kind of fix, right, the parts of the rig that aren't working right. Yeah, it's still breaking there. So really, it's, even though this tells me it's doing it right, oh, it's not. This is the problem right here. So I can even undo that. This is the problem. So get number of points. So, I mean, I could do this and say attribute wrangle. and essentially just copy this, paste this, and then see now, so for whatever reason on this wrangle, it doesn't like being bound, which kind of sucks. Oh, is that why? No, that's right. So this is outputting something wrong. But this is the cool thing is like we were able to kind of like backtrack all the way through and find, which one of these wasn't doing what we thought it was supposed to be doing. And it's like, okay, cool. That one piece needed to be fixed. So now I know if I need to make a change to this code, I just have to change it in 2 places. But other than that, now I've got, that's correct. Now I've got my low res, right? UVs are all clean and good. Geo's all clean and good. I know there's no wonkiness in this geometry, right? It's clean. It might not be perfect because our, edge flow isn't necessarily perfectly ideal, but between these two, let's go from here, right? That to that, it's the same geometry. And I could now take the normals off of this geo and put it onto this geo, right? Based off of this cop net, I could write that to disk. I don't need that. And I don't need any of this. This is my low res. And there's my high res. So now the one part that's missing here is going into the cop net, and I don't know why that's trying to display that. And finishing out that part I was showing you, which I'll have to look into that a little bit more. I haven't done that in a terribly long time, so. But there's a way in here to bring the normals in off of that. That should have taken the color information off of that. I'll find that out and then finish up this file and send it to you.
Okay. So
now, whether or not you use the tree generator or roll your own system like this, that's up to you. And might, right? Like, again, I don't want to like step in on some of that too much on that technical stuff, other than saying we just have to know that we can get what we need. Mike has more confidence right now in this, which I can understand just based on, he's worried about, are we having to learn too much Houdini in order to control something? And can we get this to do what we need it to do? Because it's a pre-rolled system. But the reality of this is there's nothing special about this. This is just a bunch of Houdini nodes. You could go through here and walk through this and start to figure out what it is they're doing, right? So they build this system here that allows them to do stuff. It's a compiled for each loop, right? That allows them to, based on what you give it, right? So like with this, we did copy stamp.
And if only I thought about to like actually plug it into the line node, because I didn't think you could plug in anything to the tree trunk generator. So it was just kind of a quick fix I didn't realize.
Right. So look here, we've done number of copies 4, and we plug this into the tree generator, and oh, that's lame. I thought that would have like looped over each one. It doesn't seem to. All right, cool. Well, that didn't do what I thought. But yeah, so, all this stuff is stuff that we can do. This is all stuff that's inside of the system. So like you look, they are even using the alligator noise just like we are. So you could go through and look at what they're doing and try to figure out, okay, cool. Like there's some nice things about having it fall off the ramp, like, so it's more gnarly at the bottom versus at the top. Their line noise is just a purlin noise. You could do that same thing manually, right? Before it goes into the polyloft. Just like this, we take an attribute wrangle and, oh, not an attribute wrangle, an attribute bop. And say turbulent noise, position into that. And I'm guessing they're adding this. Let's look how they're doing it. There's a couple ways that you can add that noise. So we're going to go inside here and find that. So there's their resample, their curve input, which is what we're using, their branch ID, and bend attributes, bend profile. Center curves, identifiers trunk, line noise. So here's the line noise, and here it is, it's point bop. And we can trace the dotted lines to see which branch it's choosing, right? So it's coming up this branch through here. So here's the point bop that it's using right here. So it's using a curl noise and this extra noise. It's adding those two together, normalizing, taking the length, multiplying that, multiplying by a gradient, which is that noise intensity ramp that you saw, and then adding that to P. Cool. So for a simpler version, just for this, you could literally copy and paste those nodes out of there, but let's just do this. And let's say curl noise, plug this in, add. You could go find all the settings that they thought were good settings. Oh, not there. We want it here. Oh, that's why. There we go. And so now this is just the purlin noise, right? And we can control how much we actually want that to add. And they were using a ramp, right? So we could do that too. We could do a ramp parameter, and we could multiply that before we add it. And we already have an attribute that gives us the length of the curve. So we can say bind, right? And that attribute that we had, there was this one, which is curve U. That was the one that the resample generated for us. Plug that into this input, and we'll multiply those two together. Now we'll come up here and we'll see here's our ramp. And we can leave it as a color ramp. Our noise type is a color, is a 3D noise. So let's actually make this a spline. We're gonna come out here. So here's our spline ramp, and we're gonna have it be more at the bottom, or maybe we want it less at the bottom, more at the top. Right, you see how you have total control now over how that works.
It makes it less intimidating.
Yeah, it's just about layering up control. You're building the ideal tool for how it makes sense to you, right? And so now if we look at our tube, right? So let's come down here to the end. No, not that one. We want this one. There's our cool tube. And now we're just going to plug in that thing that gave us some noise, right? And so we can come in here and change some of the frequency of this, right? Maybe make it less. So we get, kind of bigger breakups. All right, so it's just a matter of control on those things where you're now able to set like where those happen, so maybe we're better at 0.1, 0.1, and 0.1, but then we add another level of turbulence and maybe a little bit of roughness, right? So with each level of turbulence that we add, we're going to get more noise. Now, one thing that we are going to want to do is we're going to want to orient those. So we're going to create an orient along curve attribute after the fact. And now that messed up our things. We now need to take this and make it, there we go. So now those follow. So if we look at this, like our little things follow that. Now the problem is we get some interpenetration, right? That this polyloft doesn't know what to do with. So we get some yucky geo, which in the end ends up being like this. A simple way to get rid of that is to just reduce how many sections we have, right? And you'll see that those start to clean up a little bit. There's other things that we would do in order to kind of soften those out, but there, you're getting the beginnings of that ability to make this. And maybe we start with a lower res piece of geo here, right? So this is 50, not 150, this is 50, right? Now we're seeing like, okay, cool. We're not getting too many chunky bits. And maybe this, instead of being 100, this is only 20. And so this is what we start with. And then for adding our additional noise, right, before we do any of this, we would subdivide this. All right, so we come in here and here's what we're about to go into our attribute VOP. And we're just going to go ahead and subdivide that. And we get more geo that we can get more detail out of, right? So there you go. So it's order of operations that you have to start to determine, like, okay, you know, where do I want to have this happen? Then we come down here and we look at our quick shade, and our UVs are all still intact. Everything looks good, you know, and you can see that we've tried several different things. Like we're constantly like rethinking the problem as we're going through this. And so it gives us the ability to kind of say, okay, cool, that wasn't working. Where did the break happen? And we can be looking at the geometry spreadsheet. We can be looking at our model, and we can kind of be evaluating where we need those transitions to happen. So hope this helped.
Yeah, this helped a lot.
Cool. I'm going to save this. I'm going to send you the file. So, and then we'll talk some more later. I got to jump off. I've got my daughter's birthday tonight. So.
Oh, well, happy birthday to your daughter.
Thank you. She turned 16 today.
Oh.
So.
Nice.
Loads of fun. All right.
Okay, well, have a good night.
Cool. I'll send this over to you right now.
Okay, thanks.
Bye.
See ya.